In this lesson, we are going to briefly cover how sequences work, and to make sure you have an understanding before you go watch any of my other videos about the arithmetic sequence and the geometric sequence. So, most of you know that sequence is usually a pile of numbers that keeps on getting bigger or smaller. So in this case, let's take our sequence to be 3, 6, 9, 12. The main formula that is given to us about arithmetic sequence is un plus 1 is equal to un plus d. While this might seem a bit confusing, you have to understand all of the meanings of the variables. So if you look back at our sequence over here, you start to notice a pattern that it gets bigger by 3 each time. The amount that it gets bigger or smaller, that's what you call d. So in this case, you can understand that d is 3. And un, essentially what u means in a sequence is just a random term. It can be 3, it can be 6, it can be 9. However, it's always given to us un. And the n in the un means the number of the term. So if we have u1 is equal to 3 because the first term here is 3. So I'll give you a little challenge. What in this case is u4? I'll give you a few seconds to think about it. So u4 in this case is 12 because it's the fourth term, and so on. So if we go back to our main formula, we see that un plus 1. So for example, let's take a random term. Let's take 9 for example. So we're searching for u3 plus d and u3 plus 1. So in this case, it is said that u4 is equal to u3 plus d. So let's take examples. For instance, our u3 is 9, and we know that the d is 3 because it goes up 3 by 3 each time, and our u4 is equal to 12. Therefore, we can conclude that this is a very great formula to understand something that is next from the sequence. We don't even need to know the sequence that's going to be next, but it gives us a very great overview that each next sequence of an arithmetic sequence, you just plus d. The geometric sequence is definitely more difficult, and the formula goes out by un plus 1 is equal to un times r. So let's take a pile of numbers as well as here. 2, 4, 8, 16. And here you also start to notice a pattern that it gets 2 times bigger each time. R is the common difference here, a common ratio here. Therefore, we can understand that R is 2. And here we can do the same formula. So you already know what un is. It's just a random number from your sequence. Therefore, let's do this example also over again. Let's take, for example, u2 times r is equal to u2 plus 1. And so we get that u3 is equal to u2 times 2, because in this case our r is 2, because it keeps getting on bigger by 2. So let's put it into perspective as well, that we know that our u3 is 8, our u2 is 4, and times 2, and as you can see clearly that's correct. And this formula, both of these formulas, you can use to understand your next part of the sequence. So let's also go on how to find the common ratio or the common difference. As in this case they're quite simple, however in some cases they really are not and you have to calculate it. However, no worries, there are formulas to do this as well. So for the arithmetic sequence formula, it's actually very simple. You can calculate d by just doing un minus un minus 1. This is one of the simplest formulas in IB, and I want you always to remember this as well. So let's take the same example as well, that we have 3, 6, 9 and 12. So you can always test the formula. To get d, you take a random number of the series. For example, let's take 6. And now we know that the number of the term is 2. Let's just do 1 minus that, and we know that 2 minus 1 is 1, and we simply can get that 6 minus 3 is 3, and this is our common difference. However, geometric sequence is always a bit more complex. The formula is quite different. R is equal to un and divided by un minus 1. And we can also take our same case again, that 2, 4, 8, 16. We can always replace the numbers to make sure. And in this case, you can find the r to be, let's take 8 and 1 less than that, 4. And it's 8 divided by 4, and r is equal to 2. And thank you, I hope you understand.